Alright, today we're going to look at sign diagrams. They allow us to know where a function is positive, negative, 0, and undefined. And today we're going to look specifically at the positive, negative, and 0 uses for sign diagrams. We can find sign diagrams using graphs or using algebra. So, looking at these graphs, if we were to illustrate these on a sign diagram, we would first show where the zeros are, and we can see the zeros of this function are at x equals 1 and x equals negative 2. So we would illustrate that on our sign diagram by drawing essentially the x-axis and the points negative 2 and 1. And we can see that our function is above the x-axis. It's positive until negative 2, so we draw a little plus. And then we can see it's negative between negative 2 and 1, and then it's above the x-axis again for the rest of the function. Here, if we wanted to draw a sign diagram, we can see our 0 is at 1, right here, and we can see the whole function is negative apart from that 0. So it's negative, meaning below the x-axis from negative infinity to 1, and then it's negative again from 1 to infinity. And here there aren't any zeros, and we'll look more closely at this is a vertical asymptote. We'll look more closely at those in the next lesson, but for now, we can just talk about the idea that we also put vertical asymptotes on our sign diagrams. We can see there's a vertical asymptote when x equals 0, and we represent those with a dashed line instead of a solid line. So we have a vertical asymptote at 0. We can see the functions below the x-axis before that and above the x-axis after. And here are those same things illustrated. Notice that above the function's also written out for us. So when we have zeros of a function, it's going to cause our function to equal 0. So we can find our zeros by making our function equal to 0. So for example, x plus 2 equals 0 means that we have a 0 at negative 2, and x minus 1 equals 0 means we have a 0 at 1. So if you're not given the function, you can also find it algebraically if you're not given the graph of the function. Okay, so if we were to draw sign diagrams for these functions, we can see our 0 is at 2. So we draw our line at 2, and we know that the function's below the x-axis and then above the x-axis. So it's negative and then it's positive. Here, we've got our 0 at 1, and it's above the x-axis and then above the x-axis again. And briefly, 0. Letter G, we can see that we have a vertical asymptote when x equals 0. And the function is, because it's a vertical asymptote, we use a dashed line instead of a solid line. Our function's below the x-axis before 0, and then above the x-axis from 0 to infinity. Okay, here we have two zeros at negative 1 and 2. And we can see our function goes from positive to negative. Okay, so using algebra, we'll need to first find the zeros or the critical points of the function. We'll draw a number line with those zeros on it, and we'll test the value to decide what the sign is going to be at that interval. Okay, so what this looks like. Say we're given this function, and we first want to find our zeros. So we make the function equal to 0 to do that. we know that x plus 3 equals 0, which is going to give us a 0 of negative 3. And we also know that x minus 1 equals 0, which is going to give us a 0 of positive 1. And if you need to see that, we've got x plus 3 equals 0, when we minus 3, we get x equals negative 3, and same with x minus 1, that'll give us a positive 1. Okay, so without having to draw the graph, we can actually find the sign analysis of this function. So once we have the zeros, we put them on our number line. Now we need to test each interval. So we can choose a number less than negative 3, and we can plug it in the function. So say we choose negative 4. So we choose a number we're going to find f of negative 4, which means we'll do negative 4 plus 3 and negative 4 minus 1. And honestly, we don't even have to calculate it. All that we care about is it going to give us a positive or a negative result. So if you can see here, negative 4 plus 3 is going to give us a negative. And here we've got a negative. And a negative times a negative is going to give us a positive. So we know that that part of that interval on our sign diagram is going to be positive. Okay, we can do the same thing between negative 3 and 1. So we can choose a number between and 1. 0 is a great number to deal with, so we can try to find f of 0. And we're plugging that back into this function that we started with, so 0 plus 3 and 0 minus 1. Okay, so we get a positive number times a negative number, which gives us a negative number. And again, the value isn't as important as just is it positive or negative. In this third interval here, we just want to choose a number greater than 1. Okay, so for example 2, if we plug 2 into that original function, we'll have 2 plus 3 and 2 minus 1. And we get a positive and a positive, which is going to give us a positive when we multiply. And that's it. Okay, there is a shortcut here. So notice that every time it alternates, we have a positive, then we have a negative, and then we have a positive. So it's alternating. As long as your zeros are to an odd power, notice here our 0x plus 3 is to a power of 1, which is an odd number. And our 0 of x minus 1 is also to an odd power, the power of 1. As long as you have odd powers, they are going to alternate every single time. So if you want to do a shortcut, you can simply just use this one, which is very convenient. Choosing a number between negative 3 and 1, 0 is really quick to do in your head. If you plug 0 in and you see that, oh, this is negative, then you know the rest are going to alternate, but we only know that because these are odd powers. So odd powers cause our sign diagram to alternate. So using this shortcut, if we just came up with this negative, we would know, okay, then this has to be positive, and this has to be positive in order for them to alternate. So it goes plus, minus, plus. Okay, if you don't like that shortcut, or that doesn't sit right with you right yet, then that's okay. You can still go through this process. You can still choose a number between that's less than negative 3. You can still choose a number between negative 3 and 1, and then you can still choose a number greater than 1, and it'll still work. Okay, the zero product rule. So this is what we just looked at. If we have x plus 1 times x minus 2 equals 0, x plus 1 equals 0, which means x equals negative 1, and it also means that x minus 2 is equal to 0, which means x equals 2. So these are our two zeros in that case. Also, if we have an example like this, yeah, we should do a sign diagram of this as well. So if we wanted to find the sign diagram of that first example, we would put our zeros on the number line, so negative 1 and 2. And it's important that you always put those zeros in chronological order. Okay, using the shortcut, notice that these are both odd powers. They're powers of 1, which means that our sign diagram is going to alternate. Okay, so if we just choose a number between negative 1 and 2, for example, 0, and if we plug that into our function, 0 plus 1 and 0 minus 2, assuming our function is f of x equals x plus 1 times x minus 2. Okay, so we have a positive times a negative, which is going to give us a negative. So we know this part of our sign diagram is negative. Again, because they're odd powers of zeros, we're going to have an alternating sign diagram. So it's going to go positive, negative, positive. Okay, assuming example 2, this is our function. To find our zeros, we'll first have to factor. So we've got x squared minus 5x plus 6 equals 0. To find those zeros, we can factor, and we can take what two numbers multiply to 6, add to negative 5. And we know that's negative 2 and negative 3. So we get our zeros of 2 and 3. We can plug them in our sign diagram. And then we can choose a number anywhere in this interval. And again, notice that we have odd powers. Our zeros are raised to odd powers, which means our sign diagram is going to alternate. So we can start by choosing a number less than 2, for example 0. 0 minus 2 times 0 minus 3 is f of 0. 0. So we will have a negative times a negative, which is going to give us a positive. Okay, so that interval is going to be positive, and we know the rest of the sign diagram is going to alternate, so it'll go positive, negative, positive. And if you weren't sure, or you forgot that rule, or anything like that, you could always choose a number between 2 and 3, like 2.5, and then again you could choose a number greater than 3, and plug those into your original function. Okay, another example. So we're given this function. Notice this coefficient out here doesn't have an x with it, so it doesn't give us a 0. It doesn't really affect our sign diagram at all. To find the zeros, if this did happen to have a variable attached to it, so for example 2x, that would be another variable. So for example, if it was 2x, we would say, okay, 2x is equal to 0, and then x would have to equal 0, so that would be our one of our zeros. But there isn't an x there, it's just a constant, so it does not give us a 0. 2x plus 5 equals 0 though. So we can minus 5, we get 2x equals negative 5, x equals negative 5 over 2 as one of our zeros, and 3 minus x equals 0 is another one, and x equals 3. Okay, so we can put those zeros on our sign diagram, and notice that again they are raised to odd powers. These zeros are to the power of 1, which is an odd power, which means if we choose a number between negative 5 over 2 and 3, such as 0, and we plug that into our function, so 2 times 0 plus 5 times 3 minus 0. Okay, so we'll have 2 times 0 plus 5, 2 plus 5, 3. This is all positive. So we know this interval is going to be, of the sign diagram is going to be positive. Because they're all to powers of 1, which is an odd power, they're going to alternate. So it's going to go negative, positive, negative. So this is our sign diagram. Okay, we can also use sign diagrams to help us solve inequalities. So an inequality is written for us here. Notice this is the same function that we were working with before. So we've got our sign diagram above. This is the sign diagram of that function. And we want to know, where is this function greater than 0? So greater than 0 means it's going to be positive. So not equal to 0, just greater than 0. So we can say it's going to happen between negative 5 over 2 and 3. We can write that like this. When x is greater than negative 5 over 2 and when x is less than 3. Or we can use interval notation, not including those values. And that answers that question. So where is x greater than 0? Well, wherever the function is positive, and that only happens between negative 5 over 2 and 3. Okay, so we've got another function here. Say f of x equals 12 minus 3x squared. Again, we want to find the zeros of this function. So we're going to have to make 12 minus 3x squared equal to 0, which means 12 equals 3x squared. We can divide by 3, which means we get 4 equals x squared. Remember, when we take the square root, we need plus and minus. So x equals a positive or a negative 2. So on our sign diagram, we're going to have a negative 2, and we're going to have a positive 2. If we were to factor this, these zeros are actually only to the power of 1. To show you that, we factor this. If we take out a 3, we've got 4 minus x squared, and that's equal to, this is equal to 3 times 2 minus x times 2 plus x. So each of those, again, is only raised to the power of 1. But if you weren't able to see that, or, I don't know, weren't sure how this factored out, you could always just choose a number in each of these intervals. So you could choose a number 3 times. But because we can see that these are actually odd powers, and we know that it'll alternate, we can simply just choose 0, which is between negative 2 and 2. So if we do 12 minus 3 times 0 squared, we get 12 minus 0, which is a positive value. And again, because they're odd powers, they're going to alternate. Okay, we can now look at this inequality. We want to know where 12 minus 3x squared, the function we just looked at, which is this sign diagram, is less than or equal to 0. Less than or equal to. So it's going to be less than 0, where the function is negative. It's going to be equal to 0 at these zeros. So we can say that x is less than or equal to negative 2. So x is less than or equal to negative 2, all of this. Or we can say x is greater than or equal to 2. Okay, so that's if we want to use interval, if we want to use that notation in interval notation, we can represent the same thing by saying x is an element of from negative infinity to negative 2, including negative 2, and we can use that symbol for and, the upside down U, and x is between 2 and infinity, and remember not to include negative infinity or infinity. Okay, another example. So here we've got this as our function, and we want to find our zeros. So it's already factored for us. Do you see that? So if we look at negative 4 times x minus 3 squared, notice again, if we make this equal to 0, this is just a constant. There's no variable there, so it's not going to give us x equals 0. If there were an x there, we would have to use that to give us x equals 0. But we just have x minus 3 as our other factor, and that equals 0, which means that x equals 3 is a 0. So we've got our sign diagram. X equals 3 is our only 0. And look, our 0 is squared for the first time. It's to an even power, which means it's not going to alternate. It's going to stay the same between the interval before and after that 0. So if we look at when x is 0, which is less than 3, so we'll have negative 4 times 0 minus 3 squared. Okay, so negative 4 times a positive 9, which is going to give us a negative number. And because our 0 is squared in the original function, that negative is going to repeat itself. It's not going to alternate in our sign diagram. So because this is an even number, these are going to repeat themselves before and after that 0 of 3. Okay, so we've got negative and negative, which means if we wanted to look at this inequality here, if we wanted to solve this, this is above is the sign diagram of that function. So if we want to know where this function is less than or equal to 0, well, it's on the entire function. It's less than 0 here, it's negative there, and then it's equal to 0 when x equals 3. So we can say x is less than or equal to, or sorry, the function is less than or equal to 0 for all real numbers, or we can say between negative infinity and infinity. Okay, last couple examples. I'll let you work those out. The sign diagrams are here on the left, and I'll be sure to write the answers to each of the questions. So you can hit pause and try and work these out and then check your answers. So the answer to this one is here. can write your answer in either form. Either one.